KIRCHHOFF's law of electricity. Dear friends, we are today exploring the basics of Kirchhoff's law of electricity. What are these laws? These are two fundamental laws used for analyzing complex electrical circuits. A German physicist, Gustav Kirchhoff, has developed these rules in 1845. These rules are essential for determining current and voltage in various parts of electrical circuit. Kirchhoff's first law of electricity. Kirchhoff's first law of electricity states that in a junction in electricity, the sum of current flowing in is equal to the sum of current flowing out. It is also called Kirchhoff's current law of electricity. Figure shows that current I1, I2 and I6 are incoming currents and I3, I4 and I5 are outgoing currents. Kirchhoff's second law of electricity states that the energy supplied is equal to energy consumed. That is law of conservation of energy. It is also called the Kirchhoff's voltage law of electricity. Kirchhoff's current law of electricity. The concept of these laws is the total current flowing into a junction node must be equal to the total current leaving out of the junction. Principle based on the conservation of charge. No charge is lost at the junction. As per the mathematical form, the algebraic sum of all current at any node is 0. Kirchhoff's current law examples and applications are showing that if 5 ampere flow in circuit, 5 ampere must flow out even if it split across the multiple paths. In the real world, it is used in node analysis, grid analysis, and power system designs. Figure shows that current I1, I2, I3. I1 is the input current which is split further in I2 and I3. So I1 is equal to I2 plus I3. Kirchhoff's voltage law of electricity. It is called the loop rule. Concept of the rule is that the algebraic sum of all potential differences voltages around any node, any closed loop in a circuit must be 0. As per the principle based on the conservation of energy, the energy supplied by the source is dissipated by the components. The algebraic sum of all voltages in a loop is 0. Figure shows that voltage V is the applied voltage, I1 is the input current. It is further split up in I3 and I2. I1 is equal to I2 plus I3. Whereas V is equal to I1 R1 plus I2 R2 for first loop, and for second loop I2 R2 is equal to I3 R3. Kirchhoff's voltage law shows the example and sign conventions. Sign conventions clearly define how to handle voltage drops across the resistors and gain batteries when traversing a loop. Label all the nodes and current directions. Apply Kirchhoff's current law to the junctions to get initial equation. Apply Kirchhoff voltage law to each loop. Solve the resulting system of simultaneous equations to find unknown current and voltages, where current flowing from negative to positive sign, so the voltage represents positive sign. Here current flowing from R1 towards positive to negative direction, and hence the sign of voltage represents at R1 is negative, that is negative I1 R1. Similarly, current flowing from R2 towards positive to negative direction, and hence the sign of the voltage represented at R2 is negative minus R2 I2 R2. Therefore, V minus I1 R1 minus I2 R2, that is V is equal to I1 R1 plus I2 R2. Thank you for watching. Feel free to ask any questions in the comments below. Please do not forget to like and subscribe. Please also like to watch further videos.